Okay, you are going to need some supplies for this lesson. This is the first block of topic 13. You will need a sheet of patty paper, just one will do. You'll need a ruler, and you can use your compass. It has a ruler on the side of it. And you'll need a protractor. So if you need to, pause this video and get those supplies, and then you can restart it. In this lesson, we're going to be exploring some triangles that are cut by lines that are parallel to one of the sides of the triangle. So in question 1, you can see that you have a triangle such that you have this segment DB that is intersecting two sides of the triangle. Now, the way that it is arranged at the point on the lesson, it shows that A to D is 5.25 centimeters, and so is DE. So that tells me point D is a what? It's a midpoint, right? On the other side of the triangle, side AC, has two parts that are also congruent to each other. They are both 5 centimeters. So that tells me again that point B is a midpoint of that side. And so this segment has a special name. Segment DB is called a mid-segment. That is number 2 on your notes. So when, and I'll show you on your notes what I'm marking here, when we know segment AD and DE are congruent to each other, and AB and BC are congruent to each other, notice I changed the number of tick marks here because I'm not saying this is congruent to this. So these are congruent to each other, making D a midpoint. These are congruent to each other, making B a midpoint. This segment has a special name called a midsegment. So segment DB is a midsegment. So that is one interesting relationship when this side is perpendicular to this, not perpendicular, parallel to this side. Now, how do I know these are parallel? Well, I know they are because of these 90-degree relationships here. So I know that this angle and this angle are called same side interior angles. And if they are supplementary, meaning they add to 180, and 90 plus 90 does, then I know these two sides are parallel. So segment DB is parallel to segment EC. Another interesting relationship that can occur is when D and B are not midpoints. So the drawing now shows AD is 3.15 and DE is 7.35. So obviously they are not congruent, so D is not a midpoint. Same thing on this side. I want you to look at these ratios. So we want to look at the ratio AD, which is 3.15, over AB. So if we put that in our calculator, that ratio, I'm going to put in 3.15 divided by 3, which is the same thing as 3.000, we get 1.05. I'm going to do the same thing for the ratio DE over BC. So that would be 7.35 over 7. Notice it is also 1.05. So these ratios are equivalent to each other. So that is another interesting relationship that you can add to number 1 on your notes. The fact that AD over AB is equal to DE over BC. And again, that's only true because of this parallel relationship that exists here. So a lot of times I will call this part over part equals part over part. So these are the parts of that side, these are the parts of that side. So this part over this part is equal to this part over this part. Interesting enough, I could also write it this way, AD over DE equals AB over BC. So we just have a lot of proportional relationships that are true in this drawing that we're going to be exploring in this topic. All right, so now you need your sheet of patty paper, and your directions are just to draw a random triangle on it. And nothing special about this triangle. I just did a scalene triangle, and I want you to go ahead and label it ABC. So here is, none of my sides are the same length. It's just a random triangle, ABC. So you can pause the video to get that drawn. Make sure you use a straight edge. All right, so now that we have our random triangle drawn, we are going to find the midpoint of two of its sides. We're going to find the midpoint of AB, and we're going to find the midpoint of AC. Do you remember how to do that with a paper fold? Hopefully you remember that's a point-to-point fold. So I'm going to fold point B on top of point A. And remember, I'm just trying to locate the midpoint. I don't have to crease that whole perpendicular bisector. I'm just pinching right here because I just need this point. So I've located the halfway point between points A and B. We know that's called a midpoint. I'm going to label it with a capital letter M. I'm going to do the same thing for side AC. I'm going to fold point C on top of point A in order to locate its midpoint. Again, I'm just going to pinch it there, unfold it, and I'm going to label this N, capital N, always capital letters for points. Now we're going to join those two midpoints. Do you remember what that segment is called? We just learned it. It's called a midsegment. So segment MN is a midsegment. So now I'm going to need you to pause the video and make some measurements. I want you to use your protractor and measure all of the angles in this drawing. So the vertex, well, it's not really a vertex angle because it's not isosceles, but angle A, B, and C, and then these two angles created at points M and N. I also want you to do some measurements of side lengths. So you can measure A to M and M to B. Remember, they should be equal to each other because M is a midpoint. And then I want you to do the same with AN and NC, which should be congruent to each other, but not necessarily to AM and MB. And then I want you to measure the other two segments as well, MN and BC. And then we'll come back together to see what interesting things that we have discovered through this. Okay, so here are my measurements that I found, which of course will not be the same as yours, but the relationships should be the same. So again, since M was a midpoint, you should have the same measurement for these two segments. And since N was a midpoint, these two should be the same, but not necessarily across from each other. Those will not necessarily be the same unless you just so happen to draw an isosceles or equilateral triangle. The most important measurement that I want you to notice is the midsegment's distance compared to the third side of the triangle. Do you see the same relationship on your drawing that I have, where the midsegment is half of the third side? Because you should have that discovery as well. So the midsegment is always half of the third side, the side here. So this ratio would be a 1-to-2 ratio between the midsegment and the third side. The other thing that I hope that you discovered on your drawing is that this angle AMN, which mine was 62 degrees, is congruent to this angle ABC. Also, this angle ANM, which mine was 44 degrees, is congruent to this angle ACB. So that tells me something else that is important about the midsegment and the third side. Remember what these angles are called. Those are corresponding angles. And if corresponding angles are congruent, then what has to be true about these lines? They have to be parallel. So we should have learned two important things about this midsegment, that it's parallel to the third side and half the length of the third side. Those are the two discoveries that I hope we have learned. So on question 3 in your notes, we're going to write a conjecture. And remember, a conjecture is just a conclusion based on your observations. And so we just listed 2 observations. And so my conjecture is going to say those 2 things, that the midsegment of a triangle is parallel to and half the length of the third side. So 2 things, parallel to the, Okay, so here we can see that M and N are both midpoints of their side. AM and MB are congruent, AN and NC are congruent. So MN is a midsegment. And we can see those two relationships exist. We can tell from the slope here. It's telling me the slope of MN and BC. And we know if lines have the same slope, they must be parallel. And then it's showing me that 1:2 ratio between the midsegment and the third side. So our conjectures should match what they have as written as the midsegment conjecture, that a midsegment of a triangle is parallel to the third side of the triangle and is half as long as the third side. Now I want to look at this animation to look at some other relationships that we want to learn. Notice in this example, D and E are not midpoints because these parts are not congruent to each other. So D is not a midpoint and E is not a midpoint. So D is not a midsegment. But I want to show you, well, I don't want a second one. I want to show you the ratio here. If we look at the parts AD to AE, these two parts have a ratio of 1, and DB and EC both have a ratio of 1. I'm going to move DE, but I'm moving it and maintaining the parallel relationship with the third side. And do you still see that that relationship across the parts here is still equivalent to each other? Even if I skew it to where they're not congruent to each other, the ratio stays the same. So this part over this part is equal to this part over this part. And so that is all because of the parallel relationship though. If DE is parallel to BC, then this part over this part is the same ratio as this part. Remember, that's not a triangle side, it's a part, is to that part. So that is an important relationship for us to understand as well. Okay, we're going to complete the proof of our conjecture. And remember, once you prove a conjecture, it becomes a theorem. So this is called the midsegment theorem. And there's two parts to the midsegment theorem. We must prove that the midsegment is half the distance of the third side. And the second part is to prove that it's parallel to the third side. So I've highlighted those in different colors just to point out that those are the two things we have to prove. Our given, of course, is that points M and N are both midpoints. That, by definition, makes segment MN a midsegment. So we're going to fill in the parts. This is number 4 in your notes of this proof. So it tells me triangle ABC, which is the large triangle, and triangle AMN, the small triangle, share angle A. So we know angle A is congruent to itself by the reflexive property. And they share two pairs of sides that are proportional. So we have AM to AB. So that's the small triangle side to the large triangle side. So remember, since these parts are congruent, AM would be half of AB. And that's equal to AN compared to AC. Again, since these parts are congruent, AN would be half of AC. So both of these ratios would equal 1/2 since M and N are midpoints. So because of the angle pair, even though it's the angle congruent to itself, and the two pair of proportional sides, we know the two triangles are similar to each other by which shortcut? Well, we have two proportional sides and the angle in between them. That's the SAS similarity theorem. Now we know if we have similar triangles, then all the corresponding sides of those similar triangles have to be proportional. So that means the third side of each one of those triangles, which is MN for the small one, and that's my midsegment, and BC for the large one, would also have to have that same ratio of 1/2, because all of these sides have the same ratio with all of the large triangle sides. So we have proven part of what we were trying to prove, the fact that MN is indeed half of BC, and that's because of that 1:2 relationship between MN and BC. On the next video, I'll finish up this proof.